All right, hello once again, Jeff Scott of Rankin Technical College, and as part of the Rankin Technical College AWD or Application and Website Development 1100 C# programming class, I'm going through a series of videos where I'm trying to go through some of the fundamental topics that are explained and shown in our textbook, Murachs C# 8th edition. So I'm up to chapter 14 of 22, and this is on inheritance, how to work with inheritance. Inheritance, as it says, is a key concept of object-oriented programming. In fact, let's quickly all right, I'm just going to grab one of these. There's the 4 pillars of object-oriented programming. Okay, and I'm going to quickly talk about each one of these. So they're right here: abstraction, encapsulation, inheritance, and polymorphism. All right. So the first one, abstraction and encapsulation are very intertwined with one another. As it says, when you abstract something, you hide away the implementation details. Much earlier in these lectures, I showed you this example right here where I came in and brought up the calculator and I put in a number like 367. Then I hit the square root key. I have absolutely no idea how internally, once I hit that key, the square root key, the 367 turned into 19.1572, etc. Those details, those implementation details have been hidden or abstracted away from me. All that I can see is the interface. And if I know how to use this, so if I want to go and add a series of numbers, if I want to go and add 69, 83, 57, and 12, boom, I've done that. All I have to know is how to use the add and the equal sign. I don't have to know internally how that's being done. That information has been abstracted away from me. When you encapsulate something, it says it's the action of enclosing something in or as if it was in a capsule. All right, it's also known as data hiding. When you encapsulate, quite often, people have asked me, give me a really, really simple definition of object-oriented programming. And I said, fine, I'll give you one that's in one sentence. It's very general, it's very generic. And can you break what I'm about to tell you? Yes, it's done all the time. But in a nutshell, what object-oriented programming is about is manipulating private data using public methods. When you make data private, you are encapsulating it. You are letting the user know the only way that you can change this private data is through public methods. Now, can data be public? Yes, we've already done that in here. All right, can methods, instead of being public, can they be private? The answer is yes. They're usually called helper methods. So when one method has to call another method to get something done, that method may be private. So that's encapsulation. Then inheritance is the one we're going to go over right now. As it says, it lets one object acquire the properties and methods of another object. So it's more or less a parent-child type of relationship where the parent defines some stuff, and typically the child can define some, most, or all of it. Plus, the child can go and change what it inherited from the parent, usually. All right. Finally, there's polymorphism. That's probably the hardest one to understand. There's an example of inheritance. All right, so a dog, etc. We'll talk about this in just a minute. Polymorphism means many forms. Okay? Now, imagine that, I'm just going to show you this very quickly because I don't want to waste any more time than I already have. But I make a class that's called animal. All right? And then based off of that animal, I make a cat class, I make a dog class, I make a bird class, I make a monkey class, and I make a horse class. There could be more, there could be less. Doesn't matter. But I decide that, hey, you know what? One thing that all animals are able to do is speak. So if I call a speak method on a cat, it would purr or say meow. If I called a speak method on a dog, it would say ruff or bow wow or bark or whatever. If I called it on a bird, it might tweet. If I called it on a monkey, it would make whatever noise a monkey makes. And for a horse, it may neigh, whinny, or whatever. The point is, all right, I could use and call the same method and get different results based on the type of object that was associated with that method. That's polymorphism. All right, and this is a really good article, to be honest with you. A good place to get started. Try to remember to take that. And this is what I usually do with these. So. Just for now, I'm going to throw it up onto here, into a new document. And I'm going to, I always give attribution. This is good, though. It says it's 10 pages after I get rid of that picture, etc. And that. All right, it's already down to 9 pages. So I'll clean it up a little bit and make sure that when we get to that point, you all get a copy of it. Okay. It's also not dated. It's what I mean is it's not really old, not in my opinion at least. It's like 3 years old, so that's not too bad. All right, and it explains all 4 of these pillars that we just talked about. Okay, so let's jump back into our book then. Okay. All right, so we're going to get an introduction to inheritance, some basic skills for working with inheritance. We're going to make an enhanced version of our product maintenance app that uses inheritance. All right, then we'll talk about object types and casting, and then some work to make sure you can't do any inheritance. And that'll be the sealed classes that we'll get to at the end of the chapter. So inheritance, as it says, it allows you to create a class based on another class, and it can help design. You end up with an inheritance hierarchy. All right. Now, when we look at an example here, what we're saying is, hey, this new product that's right in here right now, this class, product maintenance.frm new product, it's a type of system.windows.forms.forms. So it automatically gets this stuff that you see on the top. It automatically string text, bool minimize box, bool maximize box, void close, void show, and a dialog result. It automatically gets that stuff. Then we can add more stuff to it. The parent class is called the base class. It's sometimes called the parent class. It's sometimes called the superclass. The derived class is called the derived class or the child class, and it's sometimes called the subclass. It just depends on the book that you read. All right, we will go over this in class. All right, So how does .NET use inheritance? You've been using it all semester, even if you don't realize it. So notice there's a class called control. And that control has a class called button base. And based off of button base, we get button controls, we get checkbox controls, and radio button controls. We've got another one called list control, from which we get our combo boxes and our list boxes, etc., as you work your way down. So as they mention here, .NET uses inheritance extensively in its own classes. All of the control classes are derived from a base control class. Some controls have, if we just looked at, the list control and the list box and combo box are children of the list control. A fully qualified name of a class includes the name of the namespace it belongs to. So not just combo box, but system.windows.forms.combo box. It's not usually used like that because you don't have to, but that is its fully qualified name. All right. Every class inherits from objects. So in other words, this is the parent or grandparent or great-grandparent or great-great. It doesn't matter of everything. An object has a few things that it provides, and that is a toString method, an equals method, a reference equals method, a get type method, a get hash code method, and a finalize method. What that means is any class you create can use these methods directly, okay? Because they inherited them from system.object. And there's a member-wise clone as well. So as I mentioned, system.object is the root-based class for all classes. So every class inherits directly from system.object, or it inherits indirectly from an object that, it's kind of like a genetic hierarchy. And if you imagine you've got a grandmother, a super grandmother at the top, all right, then she has kids that are her direct descendants. They have kids that are her grandchildren. They have kids that are her great-grandchildren, etc. When you create classes, as it says in the second bullet, it's common practice to override the toString method, possibly the equals method as well, to make it do what you want to do. The other ones typically aren't going to be overridden. How to use inheritance in your apps? Well, there's for lack of better words, there is a protocol that you have to follow. Now, we're going to look at our product maintenance app. So far, this is the entire product thing that we did. Every product had a code. Every product had a description. Every product had a price. And every product had a get display text. Now we're going to make two children. So book is a child of product, or book is a type of product. Book is a product. Software is a product. So books automatically get code, description, price, and get display text, as does software. But books also provide an author. Software also provides a version. So as it says here, you can use inheritance in your apps to create generic base classes that implement common elements of related subclasses. That's the example we just looked at. Some skills for working with inheritance. The first is, as it says, how to create a base class. So we've already done this. We made that product. Now, this stuff in here, some of this is new. If you make something, these are access modifiers. If you make something public, it's available class-wide, and it's available to any other class that wants to or needs to use it. Doesn't have to be at all related to the class. It can use it. when something is protected, it goes down the inheritance hierarchy. So if Grandpa defines something, then if Grandpa has a son, the son can use it. If the son has a son, the grandson can use it, etc. But it has to be only the current class or any class that's derived from or comes underneath that directly. Internal has to do when you're working with assemblies. I don't want to get into that because there's never really a reason we have to use internal, protected internal, or private protected in here. The last one is private, and that means it's only available within the confines of the current class. You use a base class the same way, or you create one the same way you create any other class. All right. Most of the classes you will create will be public. Sometimes the code or the data will be private. Sometimes the data will be public, depending on how you set it up. Most methods that you define inside of a class will be public. So a subclass is a child class. The way that you do this, and this is an important thing for you to realize, is by the use of a colon. The reason this is important, there's two reasons. The first is the only thing C# allows you to do is single inheritance. In other words, a child class can have only one direct parent. One child cannot inherit from two parents. Some languages, like C++, allow you to do that. C# does not. The other thing is later on in a later chapter, either in Chapter 15 or Chapter 16, I think it's 15, we will talk about interfaces. An interface is not inheritance, but it also uses this colon operator. So if you're working with subclasses, all right, the subclass can only, what comes to the right of the colon can only be one thing. If you put multiple things, it won't work. All right, great example right here. Public class book colon product. This says book inherits from product. What this means is product will handle the product's code, the product's description, the product's price, and book will handle the product's author. How does it do that? Notice the only new property we put in for book was author. And notice that in the constructor, we list everything, the code, the description, the price, and the author. But we say colon base, which means, hey, parent, you handle code, description, and price. And the parent is product. So as they mentioned down towards the bottom of the page here, a constructor of a derived class calls the default constructor of the base class before it does anything else. You use a base or the base keyword to refer to a member of the base class. Okay? You can use the override keyword to override something of a base class. What does that mean? Well, notice in here, we've got public override string. All right? And then what that means is later, since we put the word override in there, all right, this is the way that the string, the get display method works currently. But if we want to change it later, we can by overriding what it was originally. All right, I mentioned polymorphism to you. As it says, polymorphism is one of the most important features of object-oriented programming. It says it allows you to treat objects of different types as though they were the same type by declaring a base class common to both objects. If we look in here, all right, what this is saying is, since both the book class and the software class Since both of them are children of the product class, we can do things like run the get the display text method of the product base class on either one of them. All right. So as mentioned here, polymorphism is a feature of inheritance that allows you to treat objects of different subclasses that are derived from the same base class as if they were the same type of class. Same example I just gave you. If, for example, book is a subclass of product, you can treat a book object as if it were a product object. All right. What that means is a book can do anything a product can do. Usually the inverse is not true. In other words, typically a product cannot do everything a book can do. If you access a virtual member and that member is overridden, polymorphism determines the member that's executed based on object type. Kind of what I showed you before with this. Polymorphism is most useful when you have two or more derived classes that use the same base class. All right, so here's an inheritance version. So what we'll do in here, and I'm going to go again grab the version from the book, but it's an enhanced version of our app. So now you'll notice in here that when we come in to add a product, it'll depend on the type of product we want to add, and that'll be based on a radio button. So if we have checked book, we'll have the code, the description, the price, and a new author field. If it's a software, we've got the code, the description, the price, and a new version field. Other than that, the fact that one says author and one says version, they look exactly the same. New product, new product. Code description, price, code description, price. So as mentioned here, this version handles two types of products, book products and software products. And there's that radio button that allows us to do whatever it is we have to do with them. So let's see if we can bring that one in. All right, so I'm going to do a file save all on this, and I'm going to close this. Close these. And again, I'm going to come over here, right mouse click, and choose Add Existing Project. All right, and just like we did before, I'm going to go to C:\Murach /C7. Again, I've got an old copy of the book, / let's just leave it there. So C#, student download, book apps, chapter 13. So again, this is called product. Again, since I've already got it there, I'm going to have to change this. So I'm going to change the name here to product maintenance inheritance. That's not enough. I've got to also come in here. Come on, open up and change this file to another name too. All right, now if I click on this, I should have it in here. There's the other product maintenance, the inheritance one. And you'll notice that with this one now, if I run it and I add a product, oh, it's still running the old one. I'm sorry. Yes, I want to end. Got to always come in and right mouse click and choose Set as Startup Project. There we go. So now with this one, if I click Add Product, why is it still showing me the old one? I don't know. Should be inheritance. It should be running this. new product, code, and price. Well, I wonder if I brought in the wrong one. I think I brought in the one from Chapter 13, and I meant to bring in the one from Chapter 14. That's on me. So let me remove this, and let me bring in the other one. Okay, so right mouse click, add existing project. Again, C:/ Murach / C whatever, C#, student download, book applications, but I want Chapter 14. There's product maintenance. And I'm going to just change the name of this to product maintenance, INH, for inheritance. So again, I'm going to make this INH. All right, so there that is. So let's see now, and I will immediately set that as my startup project and see if that works. Now if we click Add Product, notice it says, is it a new book or is it new software? So let's add software first. And we'll put in here, I don't know, Windows 11, W11. Windows 11 software. All right, the version will be 11, and the price will be $99.99. Save. And you'll notice I've got them all together. So if I come in and add another product, and now it's a book, and I come in here and I will use C#, and the description will be Murachs C# 8th edition. The authors will be Murach and Boehm. And the price will be $59.50. And I save. I now have each kind. There's my software. There's my book. And I'm just going to remove the other one that I had in there. So now I've got one of each. Okay, if I exit. So let's take a look at that. Again, the new product form has a radio button that lets the user choose between which of these two they want to show. Do they want to show and put in a new book, or do they want to show and put in a new product, a new piece of software? The code for these, all right, you'll notice that right away here, this has been defined as being virtual. Since it was defined there as being virtual, the get display text, it can be overridden. The reason that that's important is for the book, we want to add to the end of it author, and for the software, we want to add to the end of it version. But it's two different things. This is only meant to handle these three things: the code, the description, and the price. We not only want code, description, and price for each one of these, we also want either the author name or the version number. All right. As always, when they show you what's changed in here, if there's something, what they typically do is they put it in yellow. Okay. Now, modify the behavior of the add method. Why? Because it has to know whether it is adding, what is it adding basically? All right. So it says this version inherits the .NET list product class. As a result, it doesn't need to define a list of products because it already knows that each product has got those three things. But what it doesn't know is what type of product it is. So for the product maintenance form, notice we have just one fill list box. This is an example of polymorphism because it knows when it is filling this up to put in for each product the code, the price, the description, And then it goes in and it says, okay, if you're a book, I'll also add the author. If you're software, I'll also add the version. And that's what they're talking about in here. All right, so here's the code for that new product form. And notice, if book is checked, you want to do this. Otherwise, you want to do this. Again, if it's book, author. Otherwise, version. We could have just as well checked for RB version as well as RB book. All right. And when we are checking this stuff, when we're validating, we've now got another field to validate. Either way, we've got to validate is present for the code, is present for the description, is decimal for the price. But if it's a book, we need is present author name. And if it's a version, or a software rather, we need an is present for a version. Otherwise, it's working the same as what we saw earlier. All right. Object types and casting, as it says in here, once you've learned the basics of inheritance and you've seen an example of how it works, you're ready to learn some additional techniques. This includes casting objects and getting information about an object's type. When you cast an object, you're basically saying, hey, I know you're an apple, but I want to treat you like an orange. Sometimes you can do this, sometimes you cannot. We've actually already looked at a little bit of this. So you'll notice when you work with this, there's a type class, and you can see what gets returned. I'm not going to read this to you. And they've got examples in here. Now, when you do some of this stuff, you can you can almost always treat a child as though it was a child object, as though it was a parent object. All right. Again, the reverse isn't always true. In fact, it usually isn't true. Every object has a get type that returns a type object. You can use the properties of the type class to get information about it. As it says, the properties and methods are only some of the more than 90 different properties and methods of the type class, so there's a lot you can do with it. All right, as far as casting with inheritance, this is kind of, I jumped the gun a little bit. It's kind of what I was talking about. But as it says, another potentially confusing aspect of using inheritance is knowing when to cast inherited objects explicitly. The basic rule is that C# can implicitly cast a subclass to its base class, but you must explicitly cast if you want to treat a base class as one of its subclasses. What? What does that mean? Well, think of it this way. If something is being done, if something is allowed to be done implicitly, implicitly, that means the software will do it automatically. If something is being done explicitly, explicitly, it means the programmer must do it his or herself. Now, there's typically no problem with implicit casting. All right? Typically, there's no problem with that because you're just treating a child as though it was a parent. Sometimes if you try and go the other way, it'll let you do it. Sometimes it won't. And sometimes if you try to treat a parent as though it's a child, it won't give you any error until you run the program. Then, as it says, it might throw a cast exception or something else. So, as you see on the bottom of the page here, C# can implicitly cast a subclass to its base. So you can use the subclass anywhere its parent is called for. However, you must explicitly cast a base class when a reference to one of the subclasses is required. As it says, you must explicitly cast a product object to a book if a book is expected. If you don't do that, you'll typically get one of these invalid cast exceptions. You can also use the as operator to cast from one type to another. And in that case, if you do something illegal, the program won't break with an exception. It'll just return null if you try to do something that technically you're not allowed to do. All right. Now, for whatever reason, at the end of this chapter, because we only have about 4 or 5 pages left, they take a couple of the most important topics and they throw them off at the end, and they give them very little play. Okay? If you remember earlier, I showed you this right here, this thing. And it's not the same thing, but it sort of is. As imagine for a second that I had a bank account. Okay? And what kind? Well, it might be a savings account. It might be a checking account. It might be, I don't know, an IRA account. Okay? But typically, it's kind of like, you wouldn't typically tell people, hey, I went out yesterday and I bought an animal. They'd be like, you what? All right. You wouldn't probably even say, I bought a dog. You might come down here and say, I bought, I don't know, a dachshund. All right. Or you bought, I don't know, a Bichon Frise. Okay. But you can see we're going from more general to more specific to more specific. All right. Why am I telling you that? Because what you can do is you can define up on this upper class things that everything down below would have in common. So for instance, with a bank account, I could come in there and I could define a bunch of things like the account holder's first name, the account holder's last name, the account holder's address, city, state, zip code, and maybe phone number. And that would say that regardless of what kind of bank account you were using, they all require this information. Well, then I can put it in one central repository and use it here and here and here. So I don't have to do a lot of repeating. But I'll typically take this kind of class because it is so generic in nature. Because it is so generic in nature, I will make that what's called an abstract class. An abstract class cannot be instantiated. You can't create a bank account object if bank account was made abstract. You can't create an animal object if animal was created as an abstract class. All right? So as it says, an abstract class is one that can't be instantiated. If you want to declare a class to be abstract, you use the keyword abstract with it. All right? Then typically what you put in there, so in this class, I couldn't make a class called product. I couldn't create a new product directly. I'd have to have a class that would inherit from product. But if you look in here, this would say that any class that inherits from product, since this is an abstract method, must also add this method in there. It must return a string and it must take in a string, like we've got right here. So as they mention, an abstract class is a class that can be inherited by other classes, but you can't use it to create or instantiate an object. It can contain properties, methods, and other members, like other base classes. In addition, it can create abstract methods. To create an abstract method, you put the abstract keyword in there, and you don't put in a body. And there's some stuff in here for abstract properties as well, not done as often, typically. When something is sealed, it can't be inherited. So in other words, if I were to come in here, let's use this example that we have. Now, as an example, you probably know this, but for checking accounts, there might be an interest-bearing checking account. There might be a non-interest-bearing checking account. Now, maybe for this one, you've got to have a balance of $10,000, and this one only needs a balance of $100 or something like that. But let's say that there is no special type of IRA account. There's just an IRA account. If you don't want to allow something to be inherited from, so if I didn't want to let anything inherit from IRA account, I could make it sealed. So a sealed class cannot be inherited. To include a sealed class, you include the sealed keyword in the class declaration. And they show an example right here. So in this example, you cannot have a child of book. Maybe we wanted different types of books, novels, fiction, nonfiction, whatever. You can't do that because you have said that this is sealed. And again, we'll talk about this more in class. A sealed class cannot be inherited. Sealing a class can create a minor performance improvement. You can also seal properties and methods. And you can only seal a property or method if the property or method overrides a member of a base class. I think that's it. Yep. So before I come back and continue with Chapter 15, which is on interfaces and generics, and it's not a long chapter, take a quick break, and I'll see you in a few minutes.